Alright, I'm sorry about that. So what I did over here is I drew the position graph. If you look over here, this is -1 for the area, so that's why it's at -1 here. This is at -2, so the area should be -2, which it is. And then you look over here, it's -3. The position's at -3, and then -3.5, which is that point right there, which indicates it's a min. This is a graph of velocity, so if you look over here, the slope is entirely negative to this point. That means it started in a downward direction, stayed in a downward direction. Over here, the slope is positive because it's above the x-axis, so that's the definition of min. The slope hits zero, well, equals zero, and then changes from negative to positive, and that's what happens here. And then I believe you said when you found one of these values, it was 0.25, which was at 7, and then -1.5 was the displacement over here at 6. So if you look at this graph, you can see the concavity now, somewhat, and then the final value I believe you got was 2.5 at 10. So I skipped all these values in between. You kind of get the gist of this. So if you look over here, the slope is steady. That's a -1, which is this part right here, which is that part right there. It should be a little bit more linear. And then it changes direction. So if you look over here, it's concave up, and then it becomes concave down. So there's a point of inflection over here where the slope equals 0, which actually happens to be, slope doesn't equal 0, but it does change from positive to negative, and that's the point of inflection, which is at 6, which is right there, which that is 1, 2, 3, 4, 5, 6. Yes. So now, if you actually draw this graph and you do the derivative of it, remember, this is the first derivative, this is the second derivative, this is acceleration. So if you look over here, the slope is 0, so it's right there. And if you look over here, the slope is a constant, and it appears to be 1, 2, 3, 3 across, 1, 2, 3, a steady 1, so 3 over 3 is 1. Then if you look over here, the slope of the slope, which is acceleration, appears to be a steady -0.5, which is what I drew over here. So if you want to also look at concavity, this is neither concave up or concave down because it's not above the x-axis. This is above the x-axis, so it's concave up. This is concave down, right there. And the other question that you had was the g of 7 one. That's what I was trying to explain over here. So when you look over here, g prime is equal to f of x dx, this function right here. So if you look over here, this is a graph of f of x. So g prime is the position of f of x, which is the derivative, and it appears to be 1.5. G of 7 is equal to this function, which means integrate it. So when you integrate from 0 to 7, you got 0.25, and that's when you do the y minus 0.25 equals 3/2 x minus 7, and you plug it in. I hope this helps. Third time's a charm, and I'll send this to you. Please let me know what you think. I'm sorry I forgot the volume before.